Hi folks, let's solve largest merge of two strings. If you haven't read the problem, you can take some time to read it. The problem is we are given two strings, word1 and word2, and we want to construct a new string. How to construct it? We merge in the following way. We can either pick the first character in word1, or we can pick the first character in word2. If we pick the first character in word1, then next we can pick the second character in word1, or we can pick the first character in word2. For example, first we compare C and B. We know C is better in lexically order, so we pick C. Next, we compare the A with B. B is better, so we pick B in word2. Next, we compare A in word1 and C in word2. We know C is better. So let's take a look at how to solve this problem. This is first example. We have two words and we want to merge them. First of all, we know C is better, so we pick C. Next, we know B is better, so we pick B. And we do the same. C is better, so we pick C. Okay, now the problem comes. Which A we should pick? We should pick A in the word1, or we should pick A in word2. Okay, so how do we choose? We can look ahead. We can compare substring of word1 and the substring of word2. We know the substring of word1 is ABAA. The substring of word2 is AAA. So ABAA is greater than AAA. So we can pick A in word1 so that we can reach B quicker, since B is a better character. So this time we pick A in word1 and our answer becomes CBCA. Okay, next we can pick B. Okay, now we reach the same situation. We have two same characters. So we apply the same methodology. We just compare substring of word1 and word2. And we know the substring of word2 is larger, so we pick A in word2, then we just repeat the process until one of the word is used up. Then we can append the substring of another word into our answer. So this is implementation. We know we have two indexes, and in this while loop, we just compare the substring, and we just pick the character of the largest substring, and we just repeat this process. At last, if one word is used up, then we can append the substring of another word into our answers. Now, the time complexity is O(n) squared since we have a while loop here. And when we compare the substring, you also need to scan almost all the characters. So it's O(n) squared. And the space is O(n). We know it's a little bit slow and the memory usage is high since the substring copies like all the substring of this word. It's time consuming. So we have another implementation. We can change how it compares. We don't use substring. We implement a method called greater. In this greater function, we pass original word1 and word2. We also pass the current index. Then we just compare them one by one. And don't forget to check the size. For example, we have two strings AB and ABC, and I and J is 0. Since AB are same, so it will jump out of the while loop. And we know ABC is greater than AB, so we just compare the size here. The memory usage in this implementation is much less. Previous is 400 megabytes. Now it's just 10 megabytes. Okay, thanks, folks.